What's up guys? I'm here at Ethan's house and today we're going to be firing the XM16 tank round. The XM16 is a high explosive fin stabilized round, which I'm going to tell you a little more about right now, and then it's going to pan over. So let's take a look at this new round. At the front, we've got an aerodynamic nose cone that houses a surprise for later. Next, the nose cone stretches out to a 2-inch diameter, the same diameter as the cannon's bore. The body of the round then tapers down to a 1-inch diameter. This reduction allows us to house some deployable fins. Taking a better look at the back of the round, we see 4 fins, which are deployed using 2 rubber bands. These bands store energy to deploy the fins once the round clears the barrel. Now taking a look at the surprise I was talking about under the hood. This white piece supports a nail that goes through the nose cone, and if today's test goes well, I'd like to test a fully embedded nail system. But for now, I'll leave what it truly does up to your imagination. The goals of today's tests are to confirm the consistent deployment of the fin system, confirm a straight and leveled flight, and finally, we're aiming for a nose-first impact. Now, one little problem. Ethan and I live pretty far apart, 85 miles to be exact. For my EU viewers, that's about the distance from Corsica to Grosseto. So, let's make our way down there. Let me break it down for you. See, when I was testing the round at home, I had a perfectly clean, brand new PVC pipe. But when I went over to Ethan, his old, ran through, beat up potato cannon had a little film of burnt PVC on the inner diameter. And what this meant for us was that the rounds were just a tiny little bit too big. So, as engineering students do, we ran over to Lowe's and walked around a bit just for a brainstorm. After a couple minutes, the answer was quite apparent to us. Now see, we could do one of 2 things. Plan A, which involves sanding the entire cannon barrel down to size to hopefully fit, which would take an exorbitant amount of time, but would allow for the best fit in the cannon barrel. Or Plan B, being sanding the rounds themselves. Now these 2 approaches were definitely time and labor intensive, but we saw that they both involved sandpaper, so we thought to do both. Unfortunately, I didn't record any test fitting footage. However, I found this clip which sums it up pretty well. So, it was back to the drawing board. Now, there was a secret little third plan that I didn't tell you about. See, Ethan had this older, smaller, less powerful, but most importantly, cleaner cannon. Well, we wanted to fire the projectile out of a much faster cannon. This cannon actually allowed us to fire it in the first place. So, we pivoted to use the smaller cannon. Ethan and I took the smaller cannon out to his backyard, placing it on 2 sawhorses with a custom fixture we made. Then lining it up to the target. We sighted in this cannon by putting some bog standard 2-inch diameter poplar wood and firing it at a blank target. This allowed us to hone in the cannon for the best test results. After that, we set up our data collection system. Data was gathered using 2 iPhone 15s, as well as a Sony a6700. And with all of that out of the way, all we had to do was shoot it. In these 2 videos, we can see the first round that we fired off. Despite no visual confirmation of the fins being deployed, when we recovered this round, we found signs pointing to successful fin deployment. Also, you may notice that one of our main goals was hitting nose first. And as you can see, we couldn't see that with the camera angles we had. To mitigate this, and the issue of seeing fins, we decided to put all the cameras behind the breech, meaning they were all aimed downrange, looking straight at the target. This would effectively eliminate all video artifacts as seen in the second test footage. Now, I know that footage may have been a little disappointing. We did in fact aim for the round hitting the target. However, we can make many presumptions from the flight of this round. While the fins did not provide a straight and leveled flight, they did somewhat influence the flight, veering it off course from the pre-designated target. It does mean that we can draw the conclusion that the fins did impact the flight performance of this round. Now that we've got all the tests out of the way, let's take a look at the original goals we set up for this project. Fin deployment. Although the fins deployed successfully, it's important to note that they did not work as expected. Instead of keeping the round stable in flight, they seemed to pitch the round downwards, deviating it from the path we aimed. straight and level flight. Unfortunately, we did not achieve this goal due to the fins affecting the flight profile. It is important to note that this round was not fired out of the cannon we designed it for. While the round did veer off course, this isn't the worst it could have been. It didn't end up tumbling end over end, so I'd call this a partial success. Nose first impact. Despite flying on a non-ideal trajectory, the round hit both targets nose first, even hitting nose first twice on the second flight. I would say this goal was met, as the conditions these rounds were put in would usually warrant the round to move uncontrollably, thus making a side or tail impact more likely. However, this was not the case. Anyways, thank you for watching this video. I had fun making it, maybe. And also, thank you to everyone who joined the ATF watch list with me by watching this video today. Thank you, and goodbye.